Hello everyone. I hope all of you are following the guidelines of the lockdown, and with the grace of Almighty God, all of you are fine. Today I am going to start the first chapter of Standard 10, that is periodic table and periodicity in properties. Now, what is meaning of periodicity in properties? Periodicity means if we move from left to right in periodic table, after certain intervals, there is repetition in properties by elements. I mean, suppose in the first period, there are two elements. When we start from hydrogen, then helium comes here. After interval of two elements, hydrogen and helium, 1, 2, lithium will repeat the property of hydrogen. Similarly, in second period, in which we have 8 elements, after interval of 8 elements, ninth element will repeat the property of lithium, that is sodium. Similarly, sodium will repeat the property of potassium and so on. So all the elements of group 1 will have similar properties. So periodicity in properties means when we move from left to right in the modern periodic table, in which elements are arranged in increasing order of atomic number, after repetition of certain elements, after interval of certain elements, there is repetition in properties by elements. So the elements hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, which are in group 1, all these elements in group 1 will have similar properties. Similarly, I am giving you another example, that is halogens, where we have fluorine, chlorine, bromine, iodine, astatine. So here also, if you start from fluorine, after interval of 8 element, fluorine will repeat the property of fluorine. Similarly, bromine repeats the properties of chlorine, and so on. So this is meaning of periodicity. Now question is, what is the reason for the periodicity in properties? I mean, why lithium will repeat the property of sodium and potassium will repeat the property of sodium, and so on? The reason for repetition in properties is electronic configuration. If we write electronic configuration of all these elements, it is 1, 2, 1, it is 2, 8, 1, it is 2, 8, 8, 1. So what you find is all the elements in group 1 have one element in their last shell, and properties, the chemical properties of element depend on the number of valence electron. All these elements have one electron in their valence shell, and so all these elements of group 1, we also call it as alkali metals, all these alkali metals have similar properties due to presence of one electron in their valence shell. Now coming to halogens, if you write configuration of these halogens, 2, 7, chlorine is 2, 8, 7. Similarly, if you write for bromine, the last you will find there are 7 electrons. Similarly, for iodine also in the last cell we have 7 electrons. So all these halogens have similar chemical properties due to presence of 7 electrons in the last cell. So what happens when we arrange elements in increasing order of their atomic number after intervals of 2, 8, 18 or 32 elements, their valence shell configuration becomes similar. And due to this similarity, they have similar chemical properties. So, we will discuss some of the properties of elements, how they vary from left to right across a period and top to bottom down a group. But before that, I would request all of you, though it is not in the syllabus, we have done in standard 9, please go through the modern periodic table from standard 9 book, in which we have already done it and you remember it, but just I'm asking to revise it so that you don't have any problem in understanding these, how these elements are present in which group. So, altogether in the modern periodic table, there are 7 periods and 18 groups. You know that. Vertical columns are called groups and horizontal rows are called periods. So let's discuss some of the properties what you have in your syllabus, that is in standard 10, that's first chapter, that how some of the properties of elements vary across the period and down the group. The first periodic property you have to do is atomic size. Atomic size or we also call it as atomic radius. Let's represent it by small r. Now, atoms are spherical. If atoms are spherical, then size of atom would mean what is the radius of that sphere. So it is very easy to understand that if atoms are spherical in shape, then whatever be the radius of this sphere, that will become the atomic size. But thing is not so simple, because the cells are not well defined. You will see in standard 11, electrons present in the cell are diffused in the form of cloud. I mean like this. So we don't have boundary surface, sharp boundary surface, so that we can find out the distance of the last cell from the nucleus. Because electrons are diffused in the form of cloud. If you take a piece of cotton and then roll it to give a spherical shape, you will see that it has no sharp boundary surface. So it is very difficult to find out what is the exact distance of the last cell from the nucleus. Then how do we find out? What will the meaning of atomic radius? Suppose I am giving one example. See, if we have to find out what is the atomic radius of chlorine. Chlorine is a diatomic gas. The formula is Cl2. It means two chlorine atoms are joined by covalent bond. And you know, covalent bonds are formed by sharing of electrons. And during sharing of electrons, they overlap like this. And shared electron will be in this intersection area. And see, this is nucleus of one chlorine atom, this is nucleus of another chlorine atom. Shells are not well defined, but nucleus is well defined. What we can do is, we can find out distance between the two nuclei. If we take half of the distance between the two nuclei, that is considered as covalent radius of atom. For example, in the case of chlorine, the distance between the two nuclei of chlorine atom is approximately 1.98 angstrom. So radius of chlorine atom will become, atomic radius, we also call it as covalent radius, will become 1.98 by 2, that is approximately 0.99 angstrom. So this is meaning of atomic radius. Now, what are the factors on which this atomic radius will depend? The first factor on which the atomic radius will depend is nuclear charge, means how many protons are present in the nucleus. Z. Then second, it will depend on the number of shells. Okay, now how it will depend? See, if nuclear charge increases, means number of protons in the nucleus increases, then the force of attraction by the nucleus on the last cell electron will increase, and so the radius will decrease. So mathematically we can write radius is inversely proportional to Z, that is number of protons, and number of cells. So if number of cells will increase, the size of the sphere will increase, and so the radius of the sphere will also increase. It means the radius is directly proportional to number of cells. And third factor, it is little new for you, that is called screening effect. Now what is meaning of screening effect? It's a very simple example I am giving you. When you are in lower classes, your class teacher used to give you sitting arrangement according to height. Why? Because if any taller student is sitting just right in front of you, then you will not be able to see the blackboard properly. So we say that blackboard is shielded, screened by the taller student sitting right in front of you, and you will not be able to see blackboard clearly. Similarly, when nucleus is surrounded by number of cells, see, the size will mainly depend on the force of attraction between the nucleus and the last cell electron. If there are more number of cells between the last cell electrons and the nucleus, then what will happen? The nucleus is surrounded, shielded or screened by the number of cells, and so what will happen? The effective force of attraction by the nucleus on the last cell electron will decrease. So this is meaning of screening effect. Now let us see how, considering these factors, the atomic radius or the atomic size will vary from left to right in a period and top to bottom in a group. Variation of atomic size in a group, that is downward in a group. Suppose if we take one example of the first group only, if you take hydrogen, lithium, sodium, potassium, cesium, francium. happens if you move down the group? Atomic number of hydrogen is 1, sodium is 3, sorry, lithium 3, sodium 11, 39 and so on. As you move down a group, hydrogen has 1 cell, lithium has 2 cells, sodium has 3 cells. We have seen in standard 9, it's very easy to find out how many cells are there. Just we write at the electronic configuration. The number of cells can be easily known by writing the electronic configuration. And moreover, the period number itself will tell you how many cells are present. For example, so hydrogen is in the first period, so it has 1 cell. Lithium is in the second period, so it has 2 cells, 3 cells, 4 cells and so on. Now, what happens as we move down the group? Number of cells are increasing. And so as the number of cell increases, the definitely size will also increase. Now here one question may arise, as we are moving down the group, the number of protons in the nucleus are also increasing. So size should decrease. But what happens as you move down the group? Number of cells are increasing. Of course, number of protons are also increasing. But these protons in the nucleus are well shielded by the number of cells. And so the active force of attraction between the nucleus and the last cell electron will decrease. And because of that, size increases down a group. So in any group, what will happen? Size increases. So in any group, the first element will have the smallest size and the last element of a group will have the largest size. Now let's see how the size will change, size will vary across a period. Okay, across a period means left to right. For example, suppose if we consider second period, let's. In the second period, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. The atomic numbers are 3, 4, 5, 6, 7, 8, 9, 10, for example. Now for all these elements, the number of cells are same. All these elements are in the second period, and so there are 2 cells for each element present. So number of cells is same. But as you move across the period, what you find is atomic number means the number of protons present in the nucleus is increasing. And so due to this, what will happen? The effective force of attraction on the last cell electron by the proton will increase. And due to this, what will happen? The size will decrease. So across the period, size decreases. But here is one exception for the last element. What happens? It has been found that from lithium to fluorine, the atomic radius decreases, but after fluorine, for neon, there is slight increase in size. This happens because if you write configuration, the electronic configuration of neon will be 2, 8. So what happens? 8 electrons get overcrowded. and due to this overcrowding, there is inter-electronic repulsion, and the electron will slightly diffuse, and there is slight increase in size for the neon. Otherwise, the normal trend is what? It will decrease from left to right up to halogen, but after that, for inert gas, there is slight increase in the size due to inter-electronic repulsion. So, if we summarize here, now one thing more here. In any period, the first element means the element of the first group, that is alkali metal, will have the largest side. In this case, lithium will have the largest side and fluorine will have the smallest size. Okay, so if we summarize it, radius from left to right, it will decrease, and down the group it will increase. Okay, now sometimes it's not that atom will always form covalent bond. Sometimes atom will lose electron to form cation. Sometimes element will gain electron to form anion. Now, will there be any change in size if electrons are lost or electrons are gained? Let us examine that. So, suppose if we take sodium atom, it will have some size, radius. Its electronic configuration is 281. When it loses one electron, it will form Na plus, and the configuration will become 28. So it is quite obvious from here, sodium atom has 3 cells, whereas sodium ion has 2 cells. And because of that, the size of the sodium ion will be smaller than the size of the sodium atom. So similarly, size of cation, we also call it as cationic size. Suppose if the size is here R, then say let us call it as R plus, cationic size. Cationic size. Similarly, if we take chlorine, atomic number is 17, configuration is 287. It will gain one electron to form chloride ion, 288. Now what happens here? For chlorine atom, the number of cells 3, here also number of cells 3. It means the size of sodium chlorine atom and chloride ion should be same? No, it is not same. The size of chloride ion, the chloride ion is larger than the chlorine atom. Now why it happens? When the number of cells are same, then why it becomes larger? The reason lies here. As what you find here is number of proton here, it's 17, and number of electron is 17. So 17 electrons are attracted by 17 protons. Here the number of proton is 17, but number of electron becomes 18. So force of attraction by 17 proton on 18 electron will be slightly less, and due to this, the anionic size, this we call it as anionic size. Anionic size is larger than the size of the neutral atom. Okay, so once more, for cation what happens? The size will decrease, for anion size will increase. I repeat here the explanation. What happens after loss of electron? What you find here, the number of cells has decreased. At the same time, what happens here? Here there are 11 proton, Here also 11 proton, but the number of electrons are 10 only. So force of attraction on 10 electron by 11 proton will be stronger than the force of attraction on 11 electron by 11 proton. And due to this, cationic size is smaller than the size of atom, and anionic size, anions are larger than the neutral atom. Now we have another property. Now what type of question comes from here? They can give you some, they will write, yeah, one thing very important here. I'm getting number of queries from the students asking, sir, do we have to learn the whole periodic table? And no, you don't have to learn the whole periodic table. Okay, whenever question comes, they will give you the format of that part of the periodic table. You have to understand that with the help of atomic number, how can we find out that what will be its position? I mean, in which group or in which period the element belongs. And that we have done in detail in class 9. So you should not have any problem. Again, I repeat, do we have to learn the whole periodic table? Number of queries I am getting regarding this. No, you don't have to learn. You will get learned some of these elements. Definitely for standard 10, the questions do not come beyond atomic number 20, means up to calcium. And these by practice we simply get it learned. You don't have to worry about that. So I was telling, so what happens, they may ask you, suppose they may ask you arrange, so they will give you some atoms or ions and they will ask you to arrange their size. For example, suppose if we take chlorine, Cl plus and Cl minus, and you are asked to arrange these in increasing order of their size or decreasing order of their size. So what I have said, the cations are smaller than the neutral atom and anions are larger than the neutral atom. So the largest size will be here chlorine. So if you are asked to arrange in increasing order, first you have to write the one which is smallest in size. So here chlorine ion is smallest, then chlorine atom, and then chloride ion. Similarly, suppose if you are given Cu plus and Cu2 plus. So what will happen? Size of cations are smaller always than the neutral atom. Greater the number of positive charge, smaller will be the size. So if you are asked to arrange in increasing, say here decreasing order of their size, so definitely it is already in that form, in that order like this. Okay, this type of question comes. Or they may ask you to explain why anions are larger than the neutral atom or cations are smaller than the neutral atom. 3 more periodic properties we have to do, but we keep this much for today. Before we end, usually children, what happens now in normal classrooms, when almost every day or alternate day we are going to your classes, we have enough time to give you short notes. We dictate sometime important points to for you to write down. So for that, what I am doing is I am making a PDF file of a small note with different type of question answers, and I will upload it. You can consult there. Till then, thank you very much.